Hey, welcome. So in the world of data, we're basically always trying to predict what's going to happen next. And it turns out, whether you're forecasting sales or figuring out customer behavior, it almost always boils down to answering one of two really big questions.
Okay, so let's break this down. The first type of question is all about how much. How much revenue are we going to make? What's the temperature going to be? The second type is more of a will they or won't they question. Will this customer actually buy the product? Are they going to cancel their subscription? And here's the thing. Those are totally different kinds of questions, and to answer them, you need completely different tools.
So today, we're going to build out your first predictive toolkit with 3 essential models. First up, we've got the trend finder, which is perfect for all those how much questions. Then we'll get into the probability mapper for the yes or no type of problems. And finally, the flowchart expert, which is honestly one of the easiest models to wrap your head around.
Let's start right at the beginning, with the foundation. This is the model that's really the bedrock for so many others. We're calling it our trend finder, but its formal name is linear regression.
So what does it actually do? Well, imagine you're at a county fair, trying to guess how many jelly beans are in a giant jar. You start to notice that the taller jars seem to have more beans. Linear regression is basically just drawing the single best straight line through that relationship. So, for every extra inch of height on the jar, you can predict exactly how many more jelly beans are probably inside. Simple as that.
So, bottom line, anytime you need to predict a specific number, we're talking dollars, degrees, prices, whatever, linear regression is your go-to. It's built to answer one question and one question only: how much?
But what happens when we try to use this really powerful tool for a different kind of problem? This is where that simple, trusty straight line can get us into some serious trouble.
And this is the core of the issue. I mean, think about it for a second. Can you really use a straight line, a line that can go up or down forever, to predict a simple yes or no answer, like whether or not someone is going to default on a loan?
This right here shows you exactly what goes wrong when we try to force a straight line model to do this job. We get results that are pure nonsense. I mean, look at customer A. Okay, a 35% chance of default, that seems reasonable. But customer B, a negative 15% chance? What does that even mean? And then there's customer C with a 123% chance of default. You can't be more than 100% sure of anything. The model is spitting out answers that just can't exist in reality.
And this gets to the heart of it. It's not that the model is dumb or broken. It's doing exactly what we told it to do. Find the best straight line it can. It just has no clue, no concept that our answers have to be probabilities, that they have to be stuck between 0 and 1. We're just using the wrong tool for the job.
Okay, so if a straight line is the problem, what's the fix? Well, this brings us to the hero of our story, a really simple, elegant solution called the S-curve. This little curve is the engine behind our next model, logistic regression. And here is the fix, side by side. On the left, you see our problem, that straight line that just shoots off into impossible territory. But on the right, you see the magic. This S-shaped curve is mathematically designed so that it can never go below 0, and it can never go above 1. No matter what data you throw at it, the output is always a valid probability. Problem solved. What's really cool is that this S-curve makes a ton of sense in the real world. Think about it. For someone with a super high credit score, making it a little bit higher doesn't really change their default risk, right? That's the flat part of the curve way up at the top. But for someone with a score right in the middle, a small change can make a huge difference in their probability of defaulting. That's the super steep part. The effect of any change totally depends on where you're starting from.
All right, so we've got the right model, but now we have to figure out what it's actually telling us. And to do that, we need to learn the language it speaks. And that language is the language of odds.
Now, odds can sound a little intimidating, but I promise it's not. It's just another way to talk about probability. So instead of saying there's a 75% chance of winning, we can say the odds of winning are 3 to 1. It's just the ratio of success to failure. Logistic regression thinks in odds, so if we want to understand it, we have to too. Let's make this feel really concrete. A 50% probability, like a coin flip, that's just 1 to 1 odds. Easy. A team with a 75% chance of winning, well, they have 3 chances to win for every 1 chance they have to lose, so 3 to 1 odds. And if 20% of your customers default, that means for every 1 person who defaults, 4 people don't. The odds are 1 to 4. See? You got this.
Okay, so let's put this to work. We can take some raw data, say loan defaults for people with low versus high credit scores, and turn it into a really powerful business insight in just 3 simple steps. We calculate the probabilities, convert those into odds, and then we just compare the odds.
So after we run our loan data through those 3 steps, we get to boil everything down to one single, powerful number, 3.9. This little number holds the entire insight we've been looking for.
So what in the world does 3.9 even mean? It means this: the odds of a low credit score customer defaulting are almost 4 times higher than the odds for a high score customer. And just like that, we've translated complex data into a clear, simple, actionable statement. That is the power of understanding what your model is telling you.
So we've covered the trend finder and the probability mapper. To really round out your foundational toolkit, let's just quickly look at one more incredibly useful and frankly, very intuitive model. Say hello to the decision tree, our flowchart expert. This model is awesome because it basically thinks like a person. It just asks a series of simple questions, like, is the weather outlook sunny? If no, stay home. If yes, is it windy? If yes, stay home. If no, go play golf. It just splits the data based on these simple if this, then that rules, which makes it one of the easiest models to explain to literally anyone.
All right, so let's recap your new toolkit. For any how much question, you've got your trend finder, linear regression. For those will they or won't they questions, you've got the probability mapper, logistic regression. And when you just need simple, explainable if this, then that rules, you have the flowchart expert, a decision tree. You now have a specific, powerful tool for each kind of job.
Look, understanding the right tool for the right question is the first and honestly the most important step in data science. You now have that foundational toolkit to start asking and answering your own predictive questions. So the only thing left to ask is, which problem are you going to solve first?